Hi students, this is Mr. Yao. Today we're going to talk about 7.5, where we will learn how to identify shapes in coordinate system. We are going to first review something we have already learned in the previous lesson. A quadrilateral is a four-sided polygon, depending on whether sides are parallel, perpendicular, and or congruent. They can be given special names. So quadrilateral is a general four-sided polygon, nothing special. However, a parallelogram is going to be a special quadrilateral. It has opposite sides that are both parallel and congruent. So let me draw a parallelogram real quick. Here's a parallelogram. These two sides are the same, and these two sides are the same. We don't quite use the word equal. We actually use the word congruent. It is a bit more than equal, not just the value that are the same. Congruent actually means having the same size and shape. Since it's more than just equal, we actually have this symbol right here. It's an equal sign with a little squiggly sign on the top, and that represents congruent. Parallel and perpendicular, we have learned about them, but we have never used a symbol to present them. For parallel, it's going to be two lines, two vertical lines. However, that's for when it's printed. When I actually do handwriting, it's going to be slightly tilted. So for example, AB is parallel to CD. And if it's perpendicular, it literally looks like a perpendicular sign. So it's going to be AB is perpendicular to CD. That's the symbol for parallel and perpendicular. But we're going to use those two and the congruent symbol today. Next, how do we know lines are parallel or perpendicular? We have learned in the beginning of the unit that we're going to use slopes to decide if lines are parallel or perpendicular. If they're parallel, is going to be same slopes. If they're perpendicular, the slope should be opposite reciprocal. If you forgot about that, please refer back to the beginning of the unit. Then 7.2, that's where we learned about these parallel and perpendicular lines. If we're going to prove that a quadrilateral is a parallelogram, a rectangle, rhombus, or a square, we would need to find two things for each of the sides. We're going to need to find the length and the slope. The slope, of course, is to decide if they are parallel or perpendicular, and the length is trying to decide if they are congruent or not. So this is for parallel or perpendicular. Or, of course, neither. So that's why we need to find length and the slope. That means we are going to use quite a bit of everything we have learned in previous lessons. Now let's have a look at the specific type of parallelograms that we are going to identify in this lesson. Rhombus, rectangle, and square. First, the definition for a rhombus. A rhombus is a parallelogram with four congruent sides. Parallelogram, so it's guaranteed to actually be a parallelogram first. Has four congruent sides, but has no requirement about the angles inside. All sides are congruent, but so when we try to prove it, we have to be very specific. When we try to prove something is just a rhombus, we are going to need to show all sides are congruent, but there's no perpendicular. The reason is, if they are actually perpendicular, that would become a square. So when we're trying to show just a rhombus, we're going to need to also show it's not perpendicular. Next, for rectangle, the definition for a rectangle is a parallelogram with four right angles. Just four right angles. Has nothing to do with the size. The size could be not the same or the same because a square is a special rectangle. But same thing, when we try to prove just a rectangle, so I'm going to actually write on the top, just a rectangle, that's what we're trying to prove, just a rhombus, then we're going to need to show the angles are right angles, but the sides are not all the same. Because if they are all the same, then again, special one, that's going to be a square. So we are always going to try to use the most specific name to name these, to identify these shapes. So if it is a rectangle, we need to make sure that is not even more special, that is a square. So a square, for definition, it is a parallelogram with four congruent sides and four right angles, which basically is a rhombus and also a rectangle. So it's a combination of both. That's why when we are trying to prove it is for sure a square, we need to prove all sides are congruent and all the angles are right angles. We need to show both to make sure it is a square. So again, a square is a special rhombus and a special rectangle. That's why we have to show both. But if we're trying to prove just something is just a rhombus, then we need to make sure we're showing that is not a square. So we need to show the no perpendicular. If we're trying to show something is a rectangle, we need to also show it is not a square. So the sides are not all the same. But from what I just said, you should know now, a square is still a rectangle. So that answer is yes. A square is a very special rectangle. Next, a rhombus. Well, in the definition, a rhombus is a parallelogram, so yes. The last one, if a quadrilateral is a square, what else is it? A square is a special rectangle, a special rhombus, and of course, it is a parallelogram. So when it's a square, it's actually everything. So these are a few questions for you to keep in mind. Next, so many times you guys have thought about, well, when are we actually going to use these math concepts in the future? Well, the fact is, you're not just learning the math concepts, you're actually learning a bit more. So here's a little paragraph to kind of answer that question. To some extent, the value of what we are doing today is more than just applying what we know about the distance formula, the slope formula, and polygons. Most important value of these exercises comes from teaching our brains how to stick with a long list of simple tasks. There are lots of things in life that require this type of brain power. So now let's actually get to the example. First example, the points are given. Let's have a look. Point A is 0, 1. So typically when we draw a point, we're also going to need to label the letter next to it. That's our point A. Point B is 2, 0. Point C is 4, 4. And point D is 2, 5. Then of course we're going to connect them A to B, B to C, oh, that's a bit tilted, B to C, C to D, and D back to A. Now let's find the slope. You can use the graph to do a rise over run, or let's actually use let's use the slope formula. I would suggest using the slope formula because there will be questions you're not going to be given a graph, and you still need to know how to find the slope. It's going to be, again, on the side a reminder, y2 minus y1 over x2 minus x1. So for the first pair of points, 0 minus 1 over 2 minus 0, that is going to give you negative 1 over 2, so negative 1 half. Next, 4 minus 0 over 4 minus 2, that is 4 over 2, which is 2. So BC is 2. Next, 5 minus 4 over 2 minus 4, that is going to be 1 over negative 2, so negative 1 half again. Lastly, the slope for dA is 1 minus 5 over 0 minus 2. So negative 4 over negative 2, which is 4 over 2, which is 2. So the dA is a slope of 2. Next, finding the length. So you can use the distance formula, or since we have the graph here, we can just simply draw on the graph. So to indicate our right triangles right here. So for AB is going to be a 1 and 2. So the length of AB is going to be square root of 1 squared plus 2 squared, which is square root of 5, which is 2.24. Next, BC is going to be a 2 by 4. So BC is going to be square root of 2 squared plus 4 squared, which is square root of 20. And that in decimal is going to be a 4.47. Next, CD. Same idea. CD is right here is a 2 by 1. So it's got to be a 2 squared plus 1 squared, which is square root of 5. So it's 2.24 again. Lastly, DA is square root of, that's a 2 by 4. So it's a 2 squared plus 4 squared, which is square root of 20. And the decimal would be 4.47. Now that we have found all the length and all the slopes, let's decide about parallel lines and perpendicular lines and congruent size. So, first, slope. Parallel size means they have the same slope. You can clearly see AB and CD, they are both negative 1 half. So we're going to write AB is parallel to CD. And then BC, DA, these are both 2, so BC is also parallel to dA. Perpendicular, they're a bit more for perpendicular. So here it is. These two are opposite reciprocals, -1/2 and 2, which is 2/1. They're opposite, also you flip the fraction. So AB is perpendicular to BC. And then you keep going, BC, the 2 and the -1/2, they're perpendicular again. So BC is perpendicular to CD. The -1/2 and 2, CD is perpendicular to DA. And then lastly, the 2 and the -1/2, so DA is perpendicular to AB. And now if you think about it, based on this shape, you should kind of know what it is. Parallel sides are like two sets of parallel sides, and the perpendicular basically 4 right angles, which is why when we write them down, there should be 4 pairs of perpendicular sides. That kind of makes sense. So they're all corresponding with the definition. Next, congruent size. You should see that these two are the same for AB and CD, and then BC and DA are the same. So AB is congruent to CD, and BC is congruent to DA. Lastly, based on all the information that we have, clearly we could see CD is not the same as BC, so it's not going to make it into a square, so it's going to be a rectangle, but a rectangle is also guaranteed to be a parallelogram, because the question is asking to circle all that apply. All 4 sides are not the same, so it's not a rhombus or a square. That is example 1. Now let's move on to try example 2. Very similar to example 1, so let's graph it first. -2, 6, that's our point A. 2, 1, that's our point B. -3, -2, that's our point C. And -6, 2, that is our point D. So here's our shape. Now let's find the slope and the length. So first, slope for AB, 1 minus 6 over 2 minus -2. Again, be very careful with negative numbers. You gotta subtract a negative number, so you have 2 negative signs right there. So this is -5 over 4. So that's the slope for AB. BC, -2 minus 1 over -3 minus 2. That is -3 over -5, which simplifies to be 3 over 5. Next, CD. CD is going to be -2 minus 1. Oh, actually, CD is going to be 2 minus -2 and -6 minus -3. That's a positive 4 on the top, and that's a -3 on the bottom. So -4 over 3. Next, DA. 6 minus 2 on the top, -2 minus -6 on the bottom. So it's 4 over 4. Simplifies to be a 1. Next, for the length, AB. You can draw the right triangle again, which is right here. AB is actually a 4 by 5, so it's got to be 4 squared plus 5 squared, which is square root of 41, which put in the calculator should give you 6.40. Next, BC. BC, right triangle is right here. Right here is going to be a 3 by 5, so 3 squared plus 5 squared. That is going to be a square root of 34. Put in your calculator, that should give you 5.83. Next, CD. That is going to be a 3 by 4, so 3 squared plus 4 squared. That is going to be square root of 25, which is a 5. Lastly, DA is going to be right here, and that is a 4 by 4, so square root of 4 squared plus 4 squared. That is going to be a square root of 32, which put in your calculator should give you 5.66. Now if you look at all the slopes, none of the slopes are the same, so there's no parallel lines. And if you look for the opposite reciprocal, none of them are opposite reciprocals, so there's no perpendicular size. And then all the lengths are different, so there's no congruent size either. Now, since they're all not applicable, they don't exist, it's none of these special shapes. It's just a very normal quadrilateral. So for the circle, all that apply is also going to be an A. Now there's another thing that I want to show you. For these examples, there's something that may help you to shorten the process a little bit with the length. So I'm going to start with example 1. I'm going to start circle things and see if you notice anything. So here's our slope, and here's the numbers we used to find the length. Here's our slope. Here are the numbers we used to find the length. Slope and length. Slope and length. Now let's see example 2. Slope and length. Slope and length. Slope and length. The last one, slope and length. Now you may have noticed the numbers we got from slope, not the simplified ones, just the initial numbers. If we don't include all the signs, these would just be the numbers we actually use to find the length. Well, that should actually make sense because, for example, let's say you have a CD right here. This is for CD. When you try to find the slope, you are basically doing a rise over run. The rise part in this case is so it's going down, so it's got to be a -4, and then there's a run, which is a 3. And if you look carefully, that is exactly the right triangle you would use to find the length of CD. So that's why the number 4 and the 3 are representing the legs. So basically what I'm saying is, after you find the slopes, well, you kind of need to write down the initial numbers before you simplify them. But with the initial numbers, after you find the slopes, you can just use these numbers in the slope to form your length equation. So if it's 4 and 4, it's got to be square root of 4 squared plus 4 squared. You don't need to include the signs because even if you include the signs, like a 5 squared and -5 being squared, they're the same. So you don't have to even consider the negative numbers. So just take the number, take the value of it, and then use it for the length. That should help you shorten the process a little bit so you don't have to draw all the triangles or count to know what you need for the length. That is example 2, and that is everything for 7.5. Thank you.